Hello, this is an Algebra 2 video for Chapter 3, Section 6. We will be learning today how to multiply matrices. In our previous lesson, we learned how to add and subtract matrices and how to multiply a matrix by a number, what we call a scalar. This is different in that now you will be multiplying two matrices by each other. And one thing that we talked about in the previous lesson with addition and subtraction is that the only way that you can add or subtract two matrices is if they have the same dimensions. And in a similar fashion, there's a way that you can determine whether or not two matrices can be multiplied, and it also has to do with their dimensions, but it's not as simple as saying that they have the same dimensions. So, one thing I wanted to remind you or let you be aware, if you didn't already know, is that when we talk about matrices, we usually give them a name, and that name is a capital letter, so capital A and capital B represent matrices, and these are the dimensions. So we have M by R for the dimensions of the matrix A, and R by T for the dimensions of matrix B. And what this is basically saying is that as long as the inner dimensions are equal, so when you line them up like this, and you see these are the inner dimensions, what I call the inner dimensions. So basically, the columns of the A matrix have to be the same as the rows of the B matrix. That can get confusing, so for me it's a lot easier to call it inners and outers. So if the inners are the same or equal, then that means that you can in fact multiply. It is defined. What the outer dimensions tell you, the M and the T, which are the outer dimensions, those dimensions will tell you what the dimensions of the new matrix will be. So in this case, if I have an M by R matrix and an R by T matrix, I look at the inners, they're both R, which is the same letter, so I can go ahead and multiply, and then the answer, the resulting matrix would be an M by T matrix. That's what the outer dimensions are for. I also want to just kind of let you know that we also have in each matrix, for example, if I were to say this is my A matrix, let's just be really creative here, 1, 2, 3, 4, then the A 1, 1 notation basically tells you that this is the little a represents an element that is inside of matrix A. So capital A goes with little a, capital B, capital C, and so on and so forth. So this matrix has 4 elements, and this is row 1, row 2, column 1, column 2. So the A11 is basically row and column. So this is saying row 1, column 1. So what element is in the A matrix in the first row and the first column is 1. And so therefore A2, 2 would be asking what element in the A matrix is in row 2, column 2, here's row 2, column 2, and it would be 4, and so on and so forth. So that's just kind of how you deal with the elements inside of the matrix. Just want to make sure you were aware of that. And so right now we're going to do this first example. Determine whether each matrix product is defined. Remember, it's only defined if the inner dimensions are equal. And if it is defined, then state the dimensions of the resulting product. So here we have example A, we have a 3 by 4, those are the dimensions of A, and a 4 by 2. And since I can see here that the inner dimensions are both 4, then this is definitely defined. And then the answer of the resulting matrix, it wouldn't be a 3 by 4, it wouldn't be a 4 by 2, it would be a 3 by 2. So the resulting matrix, if I were to multiply A and B together, would be a 3 by 2. And over here we have the inner dimensions being 3 and 5 are not the same, so this one would be not defined. And because it's not defined, there's no point in trying to get the dimensions of what the resulting product would be. So now you can try to do yourself number 1, A and B, and then we will go on to the good stuff. So here we have example 2, and let me tell you, this can get kind of crazy, so I just want to go nice and slow here for you. Let's go with that little guy. And the first thing I want to do is make sure that my matrices are defined. So I've got a 2 by 2 here, 2 rows, 2 columns. Same thing here. And since both of my inner dimensions are the same, that means that I can go ahead and multiply. And I also know that when I'm done at the end of my multiplication, I should end up with a 2 by 2. So I'm going to go ahead and come over here. And what I like to do is call this row 1, column 1. This is still row 1, but it's column 2. This is row 2, column 1. And this is row 2, column 2. Okay? And I'm going to show you in a second how that's going to help us. Because multiplying matrices can be really confusing if you're not paying attention. You have to multiply every row by each column. So the way that you can keep it straight is by looking at this right here. When I look at row 1, column 1, it tells me that I need to multiply this row 1 by this column 1. So I'm going to go ahead and use my highlighter here. We're going to go row 1 by column 1. So what I'm going to do is going to take 6 and multiply it by -5. So 6 times -5, which is basically row 1, column 1. All right? Then I'm going to take and add, this is still row 1, -3, and multiply that by +3. So you can kind of see what's happening here. We're going horizontal in the first matrix, and we're going vertically in the second. So this is my rows, this is my column, that gives me row 1, column 1. So this is 6 and -3 from row 1, and -5 and 3 from column 1. So that's going to be one of my elements. My one down, and you don't have to, it doesn't matter which order you go in, but I'm going to go ahead and come here now. So this element in that matrix is row 2, column 1. So now, I'm going to go row 2, but I'm still going to use column 1, if that makes sense, okay? So with row 2, I'm going to go -10 and multiply it by -5, and then add -2 and multiply by 3. So I'm always going across, down, okay? So I get those two, and now I'm going to go over here, and I'm going to do the same thing. I'm going to go row 1, column 2. Okay? So now we're going to do row 1. And this time we're going to do column 2. So row 1 is 6. And column 2 is -4. And then we're going to go row 1, -3. And column 2, +3. Okay, so again, going horizontally, row 1, but now we're using column 2. Okay, and then the last one, trying to get a different color here. The last one is for me to go row 2, which is still right here, row 2, but column 2. Okay? So row 2 is -10, and column 2 is -4. And then we're going to take row 2 is -2 times 3 from column 2. All right? So that's how you do that. So it's very helpful for you to write this out at the beginning so you have a roadmap of where you're supposed to go. So now all I have to do is just calculate the answers. Here I'm going to get -30, because that's 6 times -5 is -30. So this will just be -30. And here we're going to get -9. So -30 plus -9 is -39. And then over here we're going to get -24 and -9 and get -33. And then over here we're going to get +50 and -6, and 50 minus 6 is going to be 44. Over here we're going to get +40 and -6, and you'll get 34. So that is how you get your matrix multiplication done. So just be very careful that you keep track of the horizontal and vertical multiplication. So basically it's a bunch of adding and multiplying. You multiply these and then add the two together. So that's example 2 for you. So now we're going to let you try this one on your own. And then we're going to go to this example here, a little bit of a word problem for you. But it's not a hard one, so let's see what it says. it says, at a particular swim meet, 7 points were awarded for each first place finish, 4 points for the second, and 2 points for the third place finish. Find the total number of points for each school. Which school won the meet? So the first thing we can do is kind of put our information into a matrix. So we know that for the, let's see here, I'm going to go ahead and use this color here. For our results, we can have an R matrix, and our R matrix will be basically all the data that we have in there: 4, 8, 10, 3, and then 7, 9, 5, 3, and then 3, 1, 3, 6. So this is our result matrix. It just tells us how many first place events that they did in the swim meet. And then we know that for the points, we don't actually have a matrix for that, but we can make one. For the points, we know that you get 7 points for first place, and 4 points for second, and 2 points for third. So our matrix will look like that, 7, 4, 2. And what we want to do is basically multiply the two matrices together. So again, this is going to be a 1, 2, 3, a 4 by 3. There are 4 rows, 3 columns, and this has 3 rows and 1 column. So because the inner matrices, or the inner dimensions, are equal, then I know that my resulting matrix will be a 4 by 1. So when I multiply them together, times, okay, R times P, I'm going to get a resulting matrix that has 4 elements. They will be row 1, column 1, row 2, column 1, row 3, column 1, and row 4, column 1. All right? So this is going to be a little bit of a doozy here, but let's just see what we got. So what I want to do is I want to take my first column, which is this guy right here. Okay? I'm sorry, I did that backwards. I want to go row by column, so my rows go this way. Row, and then by column. Okay, so what we're going to do is we're going to take 4 times 7 plus 7 times 4 plus 3 times 2. That's taking all this row by that column. And then I'm going to do the same thing, only this time I'm going to go with the second row. So I'm going to go 8 times 7 plus 9 times 4 plus 1 times 2. So I've got my 8, my 9, my 1, and my columns are 7, 4, 2. Okay, then I'm going to do it again for the third column, and that's going to be 10 times 7 plus 5 times 4 plus 3 times 2. So I've got 10, so I'm going across, I'm going 10 times 7, 5 times 4, because here I'm going down, and 3 times 2. And my last one is going to be 3 times 7 plus 3 times 4 plus 6 times 2. So I'm going to get my 3 times 7, 3 times 4, and 6 times 2, going across and down. All right, so then we can get our final answers here. Let's see, 4 times 7 is 28. So we've got 28 twice here. And then we want to add 3 times 2, which is 6, so we're going to get 62. And then we have 8 times 7, which is 56. 9 times 4 is 36. And then we're going to add 2, and that's going to equal 94. And then we've got 70. 5 times 4 is 20, and 3 times 2 is 6, so we've got 96 here. And then lastly, we got 3 times 7, which is 21, 3 times 4, which is 12, and 6 times 2, also 12, and we get 45. So my final matrix will be 62, 94, 96, and 45. There we go. All right, and so now you can try that little guy. And then I will go over this little guy right here. Okay, so in this case it says find each product if G equals and H equals. So for GH, the first thing I have to check is that the dimensions are okay. So for GH, I have G is going to be a 2 rows by 3 columns, and H is a 3 rows by 2 columns. So because those are the same inner dimensions, my resulting matrix will be a 2 by 2. So I'm going to have row 1, column 1, row 2, column 1, row 1, column 2, row 2, column 2. I'm only going to have 4 elements, so that's nice. So in order to do that, we're going to go row 1, column 1 first. So row 1 is 1 times 2 plus 3 times -2 plus -5 times 1. For row 2, column 1, I'm going to go 4 times 2 plus -2 times -2 plus 0 times 1. I hope that you're starting to pick up on how that's working. So I got 4 times 2, 4 times 2, -2 times -2, 0 times 1. Okay, and then we're going to do it again. Over here, we're going to go with, where am I at here? Row 1, column 2. So row 1 is going to be 1 times 3 plus 3 times -8 plus -5 times 7. And then we're going to get 4 times 3 plus -2 times -8 plus 0 times 7. Okay, so again, in this case, I'm doing row 1, column 2. So all of these numbers, 1, 3, -5, are coming from row 1. And then these numbers in the parentheses here are from column 2, which is 3, -8, and 7. So that's pretty much all of that. We just need to finalize our answers here. So this is a 2, this is -6, and this is -5. This is 8, this is +4, that's 0. This is 12, this is 16, 0, -35, -24, and 3. So 2 minus 6 is -4, -4 minus 5 is -9. Let's put our answer over there. Let's put our answer over here, yes. Oh no, what happened there? Okay, so we want to go, what did I say it was, -9? Okay, 3 minus 24 is -21, and -21 and -35 is going to be -56. Beautiful. And then here we're going to get 8 and 4, which is 12. And here we're going to get 12 and 16, which is 28. So you get -9, -56, 12, and 28. So now we're going to do one more thing here. I kind of ran out of space there, but we want to do HG. So I'm going to do HG down here. And H is going to be a 3 rows by 2 columns. That's H. And G is a 2 rows by 3 columns. And again, integers are the same. But this is a 3 by 3, so that's going to be a little bit longer, but hopefully you'll just bear with me here. So again, I'm going to start by doing row 1, column 1, row 1, column 2, row 1, column 3, row 1, row 2, column 1, row 2, column 2, row 2, column 3, and lastly row 3, column 1, row 3, column 2, row 3, column 3. And we're going to need some space here, so I'm going to try to write small here. All right, so row 1, column 1, and I'm going to have...
1 minute.
What?
Yeah, 1 minute.
Oh, so I need to pause, and we'll get back to you.